Hello and welcome to Honors Function. In this third lecture on functions, we're going to be looking at the graph of a function and the information we can derive from it. Let's first recall the definition of a graph of a function that we've seen in a previous lecture. So given a function y equals f of x, the graph of a function is the set of, now this is not real number, this is a set of points, and I forgot the parenthesis here. It's a set of points x f of x such that x belongs to the domain of the function. Now you know what a graph looks like normally when you plot these points in a Cartesian system of axes, then you will have something that will look like this right there. Okay, so what does it mean that a point AB, what does it mean that the point AB is on the graph? Well, if this is a graph of a function f y equals f of x, then that means that B is the image of A. B equals f of A. That's what it means, that the point AB is on the graph of the function. Okay? All right. Let's start with the first example. So this should be pretty straightforward. I'm asking you, what is f of -1? F of -1 is -2. F of 0 is, it is -3. F of 2 is -5 right here. Find the output of f when the input is 1. When the input is 1, the output is -2. And find the input, careful here, it's the input that I want, when the output is 7. So output 7 is right here, right? And the input is -2. Here we go. Very, very easy. Okay? All right. Let's move on to the next example, how to draw the graph of a function. Example number 3. So in this case, you have to read the problem, okay, and draw a reasonable graph. So you must walk at a constant pace along a 70-foot straight hallway, 70 feet maybe, straight hallway to go from one classroom to another. Halfway through, you realize you forgot your binder on the table, so you turn back to get it. Input, time, output, distance from the classroom you're leaving. Okay, so here we go. Here's my system of axes. Distance will not be negative in this case, so I don't need any negative y right here. Input, time, and output, distance from the classroom I'm leaving. So at t equals 0, I'm in the classroom right here. And I walk at a constant pace. Here we go. And then, so I'm going to put, all right, so suppose this is 35. And this is 70, right? Meters. Or feet, sorry, feet. This is in feet. So halfway through, it says right here, when you're halfway through the hallway, you realize you forgot your binder. So then I'm going back, right? I'm going back. And here, I either leave at the same speed, right here, and that's it. I'm in the other classroom, right here. Same speed because these two lines are parallel, okay? Parallel. Or I could also go faster because I've wasted some times. Therefore, I need to go a little bit faster. So this is 70. So I could pick up my pace a little bit and go faster. So there are two possibilities, okay? Two possibilities. Two possibilities right here. Possibilities. Either you move at the same speed in possibility 1. Possibility 1, same pace. Possibility 2, faster, because you're late. Okay, you forgot something and now you're late. All right, let's go over example number 5. You ride on a Ferris wheel that is 50 feet in diameter and whose lowest seat is at 5 feet above the ground. Let's draw that. So here's my, well, let me draw my wheel first. Here is my Ferris wheel, 5 feet above the ground. Suppose this is the ground right here, okay? So 5 feet above the ground. Therefore, this right here is, this is 5 feet right here, 5 feet. Okay. And the diameter is 50 feet. So of course it's not, maybe it would be up to scale. This is 25 feet. All right. Diameter is 50, so the radius is 25 feet. Okay. What do we have? You make 1 revolution in 30 seconds. Input time, output your height above the ground. So let's draw this right here. All right, I think I understand what's going to happen. Here we go. So this is a time. And this is, what's the highest altitude I will be at? 50 plus 5, 55, right? 55 feet is the highest altitude. And the lowest altitude is 5 feet, okay? Because this is a Ferris wheel. So I'm either right here, and then I go around, and then I come back right here. So at this altitude, I'll be 55 feet in the air. Okay, all right. So I'm going to be moving between these two altitudes. At t equals 0, where am I? Well, I'm climbing on the Ferris wheel, right? So I'm right here. And then what's going to happen? Well, let me take the middle right here. And then what's going to happen? So I'm going to go up right here. I'm going to go up. I'm going to keep on climbing right here, right? And then I'm going to come back down, something like that. And then what? And then it's going to repeat. I'm going to go back up, and then I'm going to go back down, right? Let's try to put some indication of time right here. This is, you're halfway through. You make a full revolution in 30 seconds, so this is 15. This is 30, okay? And this, of course, is 7.5 and 22.5 right here, all right? So this is a pretty good graph. You remember these, right? You've studied them last year. We call them sinusoid. Sinusoid, okay? Next example, we'll do number 6. So number 6, we're going to have to understand this right here. So you are given a parabola right here in red, and you are given a sequence of points on the parabola. So let's call that point M1. This is going to be point M2, and this is just a generic point M right here, okay? I'm measuring, and I'm also given a point in the plane. This one is not moving. Point M, the points M will be moving. This is fixed, okay? So I want to plot the function whose output is a distance between P and M, okay? So it's a distance right here. And whose input is the coordinate of M right here. So it's a bit complicated, okay? What's going on here, okay? Let's look at these distances. Let me erase everything I marked right here. Let's look at this distance right here. I have 3 examples. One right here, one right there, and one right here. Which one do you think, if this point moves on the parabola, it moves on the parabola, which one is going to be the shortest distance between P and the parabola? I think it's going to be about here, right? If I take this point right here, I believe we should find the shortest distance right here. What's the x-coordinate of this point? Well, it's a little bit before 2. So check it out. A little bit before 2, right here, which is the x-coordinate of the point, I'm going to represent this length right here. That's the output. The output is a distance. Here, let's just say it's going to be this right here, okay? So if you call this point right here, let's give it a name. If you call this point M right here, and if this is X right here, and this is D, this is the coordinate of this point are X and D, okay? All right. If you move the point M right here, so let me take another point now. Let me go at 0. Let me go at 0. Here we go, at 0. So right now I'm going to be, my input is on my y-axis, and I'm looking at this distance right there. So it's about the double, right, than the one we had before. It's about the double. So I should expect to be around here, okay? The distance is about the double that we had before. All right. let's take one that is maybe in between right here. Let me take maybe, so I took this point, then I took this point. Let me take this point right there, So it seems like the x coordinate in this case is a little bit above 1. So maybe I'll be this way right here, okay? And this is the lowest. Now, what's going on if you move this way right here? So look, my x right here, here's another x right there, here's another x right here. See, the x are gonna move a little bit, but the distance on the other hand, see the distance is getting bigger and bigger. While the x moves a little bit, the distance is getting bigger. So look, I'm not gonna move my x a lot, right? But the distance right here is getting bigger and bigger, right? Pretty quickly, right? Okay. And in the other direction, what's going on? So I think it's going this way right here. Then you have to understand right here, it's going to be a little bit subtle. What's going on when you go through this point right here? Okay, for this point right here. Well, you're going to be changing the x's, right? You're going to be changing the x's, and then look, you're going back right there. You're going back. You're going to be changing the x's, like from here to here. The x's are going to change, but the y are not changing as fast. See? Okay, I'm going to show you the y now, okay? I'm sorry. These were the y's right here. Look, here's this y right here. Here's this y right there. Here's this y right here. See? They're not too different. They're not moving too fast. While if you go this way, even if you take two small x's right here, see, the x's are not too far from each other. The y's are very different, right? So there's a deceleration in the change of the y right here. They're not changing too much. And then let's take these two close x's right here. The y's are going to pick up a little bit more, right? And then if you take two close y right there, the y's are going to pick up even more right here, okay? They're going to be moving even more. So I think it's not something easy to explain, and maybe I'm not very good at explaining it. I think we have something like this, and then something that picks up a little bit. And this indicates that you see the y's right here. The y's are not changing too much for some given x's, right? For a small change in x right here, the y are not changing too much. But let me try to show you with a GeoSketchpad. I knew this would not be an easy explanation, so I have a GeoSketchpad right here. Check out this GeoSketchpad. So this point right here, let me take a pen right here maybe. This point right here is my fixed point. This point is the one that moves on my axis, and I'm gonna move it, okay? This point right here, the x coordinate of this point is the x coordinate of this point right there. Okay, so basically they're all gonna be under each other, okay? This is the x right here. And the y coordinate of the point is a distance here. That's d, and I'm gonna call dx right here, dx, right? D sub x. This is the point right here. And this point is going to move. Let me erase all of that stuff now. This point is going to move. I'm going to grab it and I'm going to move it. Check it out. And while I move this point right here, I'm tracing all of my point, right? So look at what we have here. The distance is increasing. And then we have right here the lowest distance. So you see this distance right here is the lowest distance. And then it's going to get a little bit bigger. But now look. I'm going to change my x, right? I'm going to keep on changing my x, but my y is going to slow down on the change right here. See, right here, you don't have a lot of change in, well, there's some change in y, but it's changing at a slower pace. And then it's going to pick up again, and we're going to have something like this. So you see, there's a feature right here that is kind of interesting. Let me see if I can increase this by moving this point. So I move my given point right here, and I want to check out what kind of graph I'm going to get if I move my given point. So here again, now it's going to increase, right? I'm going to go up. Okay, that I understand. It's going to go up for forever, for a long time. And here, my length are increasing. My length are increasing. And here they're not. They're slowing down in the increase, slowing down. and then it picks up again, and we don't see the rest of the graph. It's right here, like that, okay? So it's a little bit, and here, this way. This feature is not easy to explain, and I don't know if I did a good job or not. Anyway, let's continue with the notes. All right, guys, you're gonna do number 7, and I'm gonna do number 8. So in number 8, my point is inside the parabola. What's gonna be the shortest distance right here is it would be right here, I think, right? That's the shortest distance. So I think the x-coordinate is around -2. So around -2, I should have the shortest distance, something pretty short right here, okay, somewhere around there. And then, so what's going on if I go this way? As x increases, right, as I increase my x's right here, here's another x, my distances are, here's another x, my distances are increasing pretty fast. So I'm expecting something like this, okay, and this is the lowest point right here, something like that. Then if I move this way, here are my distances, and there will be a little bit of a slowing down right here, and then it's going to pick up again right there. So slowing down around 0. So here are my distances right here. It's going to slow down in the increase right there, and then it's going to pick up again, something like this, I think, okay? All right, I'm going to let you do number 9, and let me do number 10. Okay, so number 10, we're given an ellipse, right? So where's my shortest distance right here? I think it should be right there. So maybe for x equals 1, that's going to be my shortest distance right here. So for x equals 1, I'm expecting a shorter distance right here. Okay, then what's going on? If x equals 0, well, if x equals 0, it's a little bit bigger. Then where's my largest distance? So that's for x equals -4, right? At x equals -4, I'm going to have my further, the point is the furthest away from P. So the distance right here, so the y coordinate should be the highest right here. And then what? And then at 4, well, it's just in between, I guess. It doesn't, I don't know, I'm going to put it maybe right here at 4. What's going on at 0 right here? There's another 0. It's going to be bigger, so there is another, this 0 right here, let's put it there. This 0, okay, so I think we're going to get something like this. Something like this. And this is the smallest distance right there. Something like this, okay? So this is not a function, but we just represented the graph of a relation actually right here, okay? All right, the notes end with some recall on the graphing calculator. I hope you've used it last year. What do we indicate for a window on the calculator? We indicate the x-mean, the x-max, and the x-scale. The x-scale is how often you put a tick mark on the y-axis, okay? Same thing on the x-axis or the y-axis for the x-scale, same thing. Sometimes I will just write x-mean and x-max, and I won't indicate the scale, all right? If, for example, right here, if you had a scale of 1, when you go from -100 to 100, then your y-axis right here would be really, really, really crowded with tick mark, and it would be very thick. That's what's going on. Finally, just a quick recall on window. The window is really essential. This function is the same as this one, which is the same as this one, which is the same as this one. I haven't changed my y1. I have the same y1. What has changed is my window in all cases, okay? All right, I hope this lesson was somewhat clear. These graphs can be pesky with these distances, okay? It's a little bit acrobatic, but I hope you get the gist of it, and there will be more work on some class assignment. Thank you for watching.